System Journal. So I'm going to present a short brief progress of the journal and some information for some new audiences. So my name is Hamid Reza Karimi. I'm a professor of applied mechanics at the Politecnico di Milano in Italy, and I'm serving as the chief editor for the Journal of Complex Engineering System. So this journal is the Gold Open Access. So we are publishing the 4 issues per year. And also the good point is that up to end of 2024, so there is no APC, the article processing charges. So we are committing to the high quality publication and also in a reasonable time. And that's it. The journal is quite a rapid publication after the several rounds of the review process. So if you look at the webpage of the journal, you can, of course, you can obtain more information about the status of the journal. So the quality of the journal and the development of journal is highly belonging to basically to my colleagues in the editorial board. And we have a very large span of editorial board members in the different disciplinary areas in this complex engineering system areas. And also we are basically trying to cover the big geographical areas, and we have an editorial board from different continents. So you can see that the ratio of the female is also, we are encouraging to have more female editorial board members, and we try to increase this number in the future. So thanks to the effort of the colleagues in the editorial board, we try to basically publish the high quality papers in our journal. So these are some basically the keywords about the publication. So basically what areas is covering in the complex engineering system. So of course, if you look at this picture, you can see some main keywords, and of course it's not limited, but we try to highlight. So these are the main keywords from the AI to the control, to the system, to the modeling, to the dynamics. So all are part of basically the scope of the journal. So more information, so you are welcome to look at the webpage of the journal, and we have published 2 volumes, and each volume has some issues, and you can find more information about our recent publication on the webpage of the journal. So this is also the latest issue. So you can see, so it has been published. So that in the volume basically 2 in our issue number 2 for the volume 1, it has been published in the last December. So this is also another issue you can find it was published in the March 22. So this is also the first volume for the first issue for the second volume. So of course we are trying to cover the volume or the issue based on the result has been published in that issue, and you can get some information before reading the articles has been published in the issue. So this is also the second issue for the volume 2. You can see some the cover of the issue, and also, of course, you are welcome to look at the issue itself and try to get more information about the publication in each issue. So in the average, we are publishing 5 papers per issue. So basically, you can get the whole is open access and available online. You can download it. And I hope it would be useful for your research and try to use it in your future work. And this is also coming issue for the 3rd issue of the volume 2. And this issue will be released end of December, and that's it. So you can also get more information in 1 week, and that's it. The issue would be online. So total publications 24 up to now, but of course we are running for the issue number 4, and this will be released by end of December. So we have basically some eminent authors. Basically, we are appreciating our the subject editors, and also the very active authors and the editor board. So the Professor Kelly Cohen, so basically from University of Cincinnati. So Professor Yurun Liu, so from Yangzhou University, and Professor Jose Ragot from the University of de Lorraine in France. So you can see that what kind of publication has been published in all issues in the volume 1, volume 2, and thanks to our active board members for very contributing the high quality papers basically to our journal. So of course, we have some highly cited papers, so that you can see some articles has been published, and all the information are available on the web page of the journal if you want to get them, you want to study more details about our most cited articles. So basically why we are organizing the webinar as a part of the complex engineering system, and thanks to our publisher. So basically we are trying to promote that the result has been appeared in our issues and try to disseminate it so broadly. So that's it for today. So we have invited two distinguished speakers, and of course they have a very long-standing research in the field. So the first is our Dr. Serdar Koskun from Turkey. So he has published a very high quality articles, and you can see the title is about a comparative study of energy management system under connected driving cooperative car following case. So in this case, so basically we are trying to organize and try to encourage the people to contribute to the special issue organized by Dr. Koskun. And you are very welcome to submit your articles relevant to this issue. And you can see the title is Energy Management Control Strategies for Automated Vehicle Technologies. So up to now, the two articles has been published, but we are looking forward to get more submission to this issue. And that's it today. Dr. Koskun is going to address the topic in more details, and hopefully this presentation today can encourage you to submit your high quality papers to this special issue. So for today, so the topic is about smart mobility, because intelligent transportation system is getting widely used in different countries and getting more attention. And thanks to our distinguished speakers for today, Dr. Serdar Koskun, so from Department of Mechanical Engineering, Tarsus University in Turkey, and also Professor Ahmed Enis Setin, so he is from Department of Electrical and Computer Engineering, University of Illinois in Chicago. So today we have a two interesting presentation, and I invite all of you to actively participate in the presentation. And if you have any question, so feel free to join our discussion after finishing the presentation by these two distinguished speakers. So first, we are starting with the first speaker is Dr. Koskun. So he received a bachelor's degree in mechanical engineering from Illinois University in Turkey in 2010, and also MSc degree from the Houston University in 2014, and also the PhD degree mechanical engineering from Texas A&M University, so in 2018. So he is currently assistant professor with the Department of Mechanical Engineering, Tarsus University. So he has involved in many scientific projects and published high quality papers and more than 25 articles in the journal and conferences. So his current research interests include energy management of hybrid electric vehicles under platooning, and also cooperative adaptive cruise control and human-like cooperative, non-cooperative decision-making algorithm for autonomous driving. So today, Dr. Koskun is going to address his presentation, and following him, we have another distinguished speaker, Professor Setin. he is going to present his lecture after finishing the first presentation by Dr. Pascal. So we have the tight schedule for today. So I don't want to talk more as a welcome remarks. So then the floor is given to Professor Koskun, and he's going to give a presentation with the title of Autonomous Driving Technologies for Hybrid Electric Vehicle Energy Saving. And as I mentioned that later, Professor Setting, he will talk about the energy efficient signal processing machine learning algorithm. And please keep your question for our discussion. So after finishing these two presentations. So thank you very much for listening. And now the floor is given to Professor Koskun. The floor is yours, and please, you can start your presentation if you're ready. Thank you.
Thank you, Professor Karimi. Now I share my screen presentation. So I think it's good, right?
Yes,
it's good. Thank you again, Professor Karimi, for this webinar and OIE Publishing Services. And today I will give you some. I will give you a presentation about autonomous driving technologies for hybrid electric vehicle energy savings. Let me give a little bit about myself. So I am an assistant professor of mechanical engineering here at Tarsus University. I do research in control system area, ranging from robust control to adaptive control, as well as predictive control design. So my application area is on autonomous and electric vehicles development. So I apply the control techniques, new control techniques in this trust area. As the name states, I will start with the definition of an autonomous car. So as we can see, autonomous car is capable of sensing its environment and operating without human involvement. In this regard, a human passenger is not required to take control of the car at any time. Autonomous car, as seen here, can go anywhere like a traditional car does. For that, it has some sort of features. So in terms of driving systems, which is also called as driving assistance systems, autonomous cars are equipped with variety of them. I can first tell adaptive cruise control, which is one of the earliest version of autonomous driving technologies, which can help you to determine the speed that your car can go along the way without your involvement, right? So you kind of exchange the driving task between you and the computer, right? In autonomous driving. So I can also talk about parking assistance system as an advanced driving assistance system, which can also help you to safely park your car in a designated area. And autonomous cars, as seen here, mainly rely on sensors, actuators, complex algorithms, machine learning methods, right? Machine learning algorithms. And they have powerful processes to execute behaviors on roads. In this regard, I will give you a little bit more about autonomous cars. They can create and maintain a map of their surroundings based on a variety of sensors situated around them. So maybe at each corner of the car, there are a variety of sensors. They can help receive information in traffic. So based on those information, these intelligent vehicles can do some tasks instead of a human driver. So in this regard, the technology that plays a key role here are many. We have talked about autonomous vehicles, which I will go detail in the sequel. So we have another title: connected vehicles and electric vehicles together. They form smart mobility. So one question you might want to ask is: connected autonomous electric vehicle is possible? So what type of technology is needed in order to ensure the safety and efficiency as well as higher mobility on roads? So the driver tasks using various artificial intelligence algorithms under different types of traffic participants, such as human-driven vehicles, autonomously driven vehicles. How about that? So can an autonomous vehicle perform its task under a variety of traffic participants, different types? Is it possible? So what type of technology needed to ensure the safety of autonomous vehicles? So as the name states, we will mainly talk about autonomous driving technologies. And first of all, I will introduce some of them here in a part one. Then I will try to blend those technologies in hybrid electric vehicle energy saving. So which is the main objective of the webinar. So what type of opportunities available for us so that we can leverage these driving technologies for hybrid electric vehicles, not just from the safety viewpoint, but also energy consumption viewpoint, right? So there is an unfortunate fact that a big number of people were killed in motor vehicle crashes. These are mainly due to human errors or poor decisions. And it is very common that while driving, you might get distracted. You might be not very experienced in the traffic situation that you are in. So in this regard, these assistance systems can take fully control the autonomous vehicle and can drive. Then it can be a self-driving car. But as we discussed at the beginning, so what do we really need for that? As we discussed at the beginning, we need sensors, complex algorithms, actuators, and machine learning algorithms, so forth. So here I will particularly focus on one type of autonomous driving system, which I call here as a decision maker, right? A decision maker to let the car to make decisions instead of you. For that, mainly we divide this decision-making process into two parts, in higher level and lower level parts. So in the higher level part, this car receives information about the traffic participants, or infrastructure, traffic signs, or traffic lights. And based on this information, using some sort of artificial intelligence methods or control algorithms, it can execute decisions. These decisions can be changing lanes, right? Or accelerating, decelerating. In the lower level, mechanical controllers using actuators perform the task in the lower level as seen. So even though I started from the top of this figure, from environment all the way from top to bottom, but first thing that we need to be aware of that are vehicle dynamics. So we want to control it, right? We need to know the dynamics first, actually. But in this discussion, we are going to be more talking about this decision making as an driver assistance system driving assistance system. So I just want to give a brief definition of decision making, which is to choose the best solution among several alternatives. In an autonomous driving case, what we need to do using sensors, we receive information and we monitor, observe this information. Probably we don't just do it one time. Since traffic is a highly dynamic process, so we do this at every sampling time, right? At any time of the driving. Then using this information, which I call in car spraying, using some sort of artificial intelligence methods, we execute decisions, right? We accelerate, decelerate, changing lanes, or stop. All these are possible. So regarding this decision making, I don't want it to be a value here. So I will give a specific example. Let's consider a 3 lanes highway driving, and we have several cars, and our autonomous car is seen as red in the middle. So it needs to change lanes because there's a danger in the middle lane, in front of, ahead of it. So probably the white car in front of has stopped. So this guy needs to observe the environment and needs to make decisions based on the highly dynamic traffic situation. So how to do this? Mainly, this car uses the relative positions, velocities. At the same time, this guy needs to be in interaction with other vehicles because maybe at a particular time it decides to change lanes, but then it can abort and it can redecide to do other decisions, right? So in order to make this example more clear here, in a traffic situations, we might have human-driven vehicles, right? And we might have autonomously driven vehicles, or we might also have connected vehicles, as seen here. So these connected vehicles basically share information through some sort of communication channels, which I will be talking about that soon. And autonomous car, if it wants to, for example, merge, or if it wants to cut in one of the gaps, available gaps in the surrounding, so it needs to take account all these interactions between autonomous vehicles, between itself and human-driven vehicles, as well as connected vehicles on the road. So there are a lot of things going on. So most car developers, especially autonomous vehicles developers, test their algorithms in real time by driving this type of cars millions of miles to make sure that it is safe enough and it can really prevent accidents instead of creating accidents. So in our case, we test our algorithms in a lab, which I conducted research in this area back in my PhD, and I also continue to work on that. So considering the previous scenario, I derived a human-driven car. So the other cars are connected, and we have an autonomous vehicle, which is the yellow car. So I prevent this guy from changing lanes. Why do I do that? I just want to see the behavior that autonomous car can perform with respect to the other participants' behaviors, right? I can be cooperative or non-cooperative depending on the situation. So what are the challenges? Code, cybersecurity, of course. For such a system to run smoothly, it requires a big number of lines of codes. So as the design complexity increases, testing and validation becomes more crucial to make sure that everything runs smooth. And cybersecurity, which we will talk about connected vehicles momentarily, cybersecurity is a very important issue because autonomous and connected vehicles are really vulnerable for cyber attacks through communication channels. So without stopping, let us go for connected and autonomous vehicles. So connected and autonomous vehicles combine connectivity and automated technologies to assist or replace humans in the task of driving, as seen. This can be through combination of advanced sensors, onboard and remote processing capabilities, as well as global positioning systems or telecommunication systems. So as we previously discussed, autonomous vehicles use technology to steer, accelerate, and decelerate little or no human involvement. Connected vehicles at the same time use technology to communicate with each other and change state information, for example, in a task of platooning, let's say. They can also receive information with the traffic objects, and this information will definitely help for traffic safety, and it will increase the mobility, right? And the number of these cars, these type of connected vehicles, will increase in the future in the world because they are a viable option for human driven cars. And this some questions, of course, how do we need why do we need connected vehicles, as we talk about the safety concerns and as well as environmental concerns. We will talk more about that. And the types of, what are the types of vehicular connectivity, and how do connected vehicles communicate, and what are the advantages? As seen in this slide, we have several vehicular communication channels. So one is, let me introduce vehicle-to-vehicle communication channel, which basically exchanges their information between each other. So that's the main idea. And vehicle-to-cloud communication leverages vehicle-to-network access to broadband cellular mobile networks to offer data exchange with each other. So in this regard, vehicle-to-network also stands for the network communication. They can access the vehicular information and maybe change, and the network can share this information with other vehicles as well, right? In a smart mobility case. Vehicle to infrastructure generally refers a vehicle can have information about traffic lights, road signs, so forth. And vehicle to pedestrian also, between vehicle and a pedestrian. Vehicle to mobile, which generally happens through a Bluetooth connection. And vehicle to home, especially for electrified vehicles, a vehicle can access the power management of a house, or vice versa. They can exchange information regarding the battery level and so forth. And why connected and autonomous vehicles are important? Because there's a big number of people were killed in the motor vehicle crashes. So this technology is a viable step to increase safety, as well as a greater mobility is a promising feature as well. Efficiency and respecting the environment is another point. And of course, these technologies will also create new job opportunities at the same time. Definitely there are challenges in terms of infrastructure, market introduction. You need to convince people that these cars are safe and efficient and they are reliable. Also legal issues, traffic management and decision-making algorithm parts has also different challenges, but researchers all over the world solve these problems step by step. So as we discussed in the first part, autonomous vehicles operate much more efficiently than conventional vehicles, and human involvement with automation, human involvement in driving is reduced. And connected and autonomous vehicles combine connectivity and automated technologies at the same time. And communication, cybersecurity, navigation, collisions, and pedestrian involvement need to be carefully investigated. And so here in the second part, so how we can leverage all these technologies in hybrid electric vehicle energy saving. A brief introduction. Hybrid electric vehicle is a type of electrified vehicle which basically uses two sources of power, and their energy management generally relies on optimizing the power or torque distribution between two power sources. So energy management in this sense in hybrid electric vehicle is basically finding the optimal power split energy sources. In this case, it is an internal combustion engine and electric motor, for example, and the powertrain structure is also given here. So how does this work? So we discussed at the beginning that hybrid electric vehicles energy management have been studied from different perspectives. In this case, we will focus more on three main categories: single vehicle, double vehicle, and multi-vehicle case. Single vehicle case then generally considers the external factors like road information, and but double vehicle and multi-vehicle vehicle cases mostly consider surrounding vehicles and traffic information, route information all together, because they use some sort of car following modes like adaptive cruise control or predictive cruise control, which we will talk. So in these main categories, energy management strategies are divided so in single vehicle case, using the information, route information, road slope, and external factors, a power split is achieved from the perspective of minimizing the fuel consumption. But for double vehicle case, the idea of energy management is basically built on the top of car following mode. So what I mean is that in this case, the vehicle A, in this case, vehicle A receives the information of its preceding vehicle, not just for energy savings, but also to maintain a safe inter-vehicle gap. So here, we consider a situation where this vehicle A and B are connected, right? They exchange their information through a communication channel. It might be vehicle to vehicle in this case. At the same time, let's say these two cars receive information about infrastructure, right? Traffic light signal times, for example, traffic light state, as well as information through these channels, information of the preceding vehicle, such as speed and acceleration. So once those informations are available, using a proper objective function, we can determine optimal power split considering the traffic environment, right? Traffic interactions. So why this is promising? This is promising because we just don't optimize the energy management for a single car. So we do that for double vehicle, maybe more, multiple vehicle cases, which I will show in the sequel. So there are two strategies available for double vehicle case. First one, adaptive cruise control base, which basically tries to maintain a inter-vehicle safe gap. At the same time, determine the best power split in the powertrain level. The second option, which is available to us in the literature, is predictive cruise control. So this predictive cruise control mainly obtains mainly predicts the preceding vehicle velocity or acceleration up to a certain horizon, and using those predicted values, follower hybrid electric vehicle can determine its optimal velocity as well as optimal power split up to a certain horizon. So using this prediction, the algorithm can be more robust to driving cycles, and changing conditions in driving can be better captured. So multi-vehicle case, which I show this figure maybe in one longitudinal direction, but it can be extended to lateral case as well. So maybe these cars are also changing lanes altogether, right? In a truck case, let's say. So the communication devices such as vehicle to vehicle and vehicle to infrastructure and pedestrian, all these considerations are needed. They need to be taken account carefully for multi-vehicle case, because we want to optimize a global power energy consumption in this case, such that vehicles, connected hybrid cars can travel safe and they can minimize their overall fuel consumption. So a control algorithm that can take into account all these factors need to be carefully designed. And as we discussed energy management strategies in the previous slide, so energy management strategy in this case, considering the external factors as well as considering the dynamic traffic changes, they can find optimal power split. So here we can design a control algorithms, but considering all these details, we cannot design a control algorithm considering all these details under one roof. Maybe we might need to split the problem into several sub-problems and try to integrate each part, which cannot be really easy, but it is a really promising problem to solve a big problem here. So what to really take away in today's presentation, we talk about vehicular connectivity, how they can be achieved through network channels, communication channels, and these informations are really useful not just to follow connected vehicles each other, but also to determine their power split, their power management at the same time. And of course, designing these algorithms requires several considerations at the same time. But what is really promising, available autonomous driving technologies, available research allows us to apply this in a hybrid electric vehicle energy savings, so that a global optimization can be achieved. Here, I want to special thanks go to Complex Engineering Systems editorial office for organizing this webinar. And regarding my presentation, I will be happy to answer your questions in the question and answer session. Thank you very much.
Thank you very much, Dr. Kostun, for this excellent presentation. This is a very challenging topic and very interesting. So I hope the audiences can come up with some questions in the Q&A, the time slot. So thanks, Serdar, and then we can continue with the speaker. So I try to share the screen and then okay, so now according to the time schedule, so it's the time for the presentation of the Professor Ahmed Enis Setin. The title is the Energy Efficient Signal Processing and Machine Learning Algorithm. So Professor Setin, he got a BSc degree from the Ankara. So, and also he got the master and the PhD degrees from University of Pennsylvania in 86 and 87, respectively. So Professor Setin, he has a very impressive CV and the curriculum. So he's the IEEE fellow, and also he's serving as the editor-in-chief also editor board for several journals. So especially the journal we can say he's serving as a chief editor is a signal, image, and video processing. So process setting, so the floor is yours. So if you are ready, so we are looking forward to listen to your presentation. Process setting, are you in the room or? So it seems he's not in the session. I tried to contact him. So sorry for this inconvenience. So I'm trying to contact process setting. Maybe he has some connection problem. So we try to solve it as soon as possible. Okay, so because of the maybe we are waiting for the connection of process setting, so maybe we can a bit shift the time schedule and keep some Q&A for the first presentation. So from the audiences, so in the meeting room, so if you have any question, so basically for Professor Selva Koskun, if you have any questions, so you can raise your hand or you can drop your question in the drop box, in the chat box, and then Dr. Koskun, you can address your question. Is there any question for the first presentation? Maybe no question, but of course, after the second presentation, we will come back again to the Q&A. So it seems Professor Setting is not trying to get connected. So
Hello everyone, please wait a moment and Professor Setting just accepted to the YouTube channel and he'll come soon in the Zoom meeting room. Please wait a moment. Thank you.
okay, thank you. So now he's trying to join us in a few seconds. So
Yeah, I just don't know how to access to the Zoom meeting and just go to the wrong channel. So please wait a moment. Thank you for your patience.
Hello, everyone. Sorry about this problem. I did not have the Zoom link. Can you hear me?
Yeah, hello, the process setting. So it's great. So to meet you online. Thank you very much for your time. Yes, so now we are the floor is yours. I have already introduced you to the audiences
Okay.
and also the topic of your
Uh,
presentation.
Thank you very much. So, hello, everyone. Sorry about this problem. I did not have the Zoom link. Can you hear me?
Yeah, hello, the process setting. So it's great. So to meet you online. Thank you very much for your time. So you can share your screen if you are ready.
Okay. Just a second. Okay, share screen. Okay, so let me also, I thought they are going to present my slides, so let me also share my slides. Okay. Just a second. Okay, so energy efficient signal processing and machine learning algorithms. My interest to this area started when I was designing this camera. This is a camera, okay? So it looks weird. It's designed in 2004. It's a wide angle camera and it has an ARM and a GPU inside. So it's a wide angle camera. So it receives this wide angle fisheye image and then it corrects it and generates this panoramic image and produces the panoramic image as the output. This is mainly due to the GPU inside the camera. And the camera was successful. There is this company that I co-founded, and it's received even some press items. And the problem is that we have to cool the GPU. You see the cover. This is a video recording unit, and it has a lot of coolers. That's why the aluminum case became much more expensive than the electronics, and it was expensive and hard to produce this aluminum case just to cool down the system. So the current vehicles have to use GPUs, and they consume a lot of power. And so I will describe energy efficient image processing or video processing algorithms in this talk. What happens is that we introduced an operation to replace the multiplications. Multiplications consume a lot of power in processors. And so to multiply two numbers, quote unquote, multiply two numbers, we have, let's say, two real numbers, x and y. We determine their sign, x times y, and then we take the absolute value of x plus y. This is inspired by the fact that x times y is equal to sine of xy multiplied by absolute value of x times absolute value of y. Okay, so we replace the multiplication sign here by plus. So 2 times 3 makes 5 in our notation. And 1 times -3 becomes -4. This approach is used in signal processing, or related approaches are used in signal processing. There is the sine LMS adaptive filtering algorithm introduced in 1980s. In fact, the LMS algorithm, adaptive filtering algorithms, are used in modems and everywhere. And they are the predecessors of neural networks. So our operation is multiplication free because sine xy can be calculated by using the sign bits of xy, and then we have additions. Once we have the sine x, this multiplication, we can define inner products like this: x transpose y is equal to summation I sine xi yi, absolute value of xi plus absolute value of yi. So this is a vector product here. X transpose y is equal to summation I xi yi. This operator has some properties. It's L1 norm. It induces L1 norm. So X transpose operator X, the regular dot product induces the L2 norm. In this case, X transpose X is equal to summation I sine xi absolute value of xi plus absolute value of xi, and it's just 2xi. Now, the idea is that we can use this operator in neural networks and other machine learning algorithms, okay? In other machine learning algorithms, we can build a covariance matrix similar to the regular covariance matrix. Instead of multiplication, we now use this operator. Unfortunately, this matrix, A matrix, may not be positive semi-definite in general. So it is not a Mercer type kernel. It does not introduce a Mercer type kernel, but we developed neural network algorithms and other machine learning algorithms based on this operator, and it works. Recently, we developed another version of this algorithm, and we have now the kernel property. So we have a well-defined mathematics behind it. So this is the new operator. X operator y is equal to sine x times y, minimum of absolute value of x and y. So in this case, we have 3 times -1 is just -1. 2 times 3 is 2. So what happens is that we just consider these 2 and 3 as sets, for example. The intersection of 2 and 3 is just 2. Okay, and 3 and -1 does not intersect. Therefore, I have a -1 here. And in terms of their magnitudes, the amount of non-intersection is -1, negative or +1. So we have -1. So that's the idea behind this new operator. And we can generalize it into the vector form. X transpose Y is summation I sine Xi, minimum of absolute value of Xi, Yi. We have a theorem. This is a Mercer type kernel. It generates a positive semi-definite Gram matrix. In other words, I have this kernel. There is a kernel operator, Kxy, which is equal to phi x, phi y. So if you are given two vectors, x and y, then we have a function mapping the x to another function, phi x, and there exists another function, the same function, phi takes the vector y to phi of y. Then in the new domain, you perform a well-defined dot product, and that dot product happens to be equal to summation I sine Xi, Yi, minimum of Xi, Yi. I'm going to show you how this phi looks like in my next slide. So this operator satisfies the reproducing kernel Hilbert space framework, and it has the L1 norm property X transpose dot, or X dot X or X transpose X is just the L1 norm. Okay, the other one was generating 2 times the L1 norm of X. Now this is generating just the L1 norm of X, which is, you know, the determined by the summation X absolute value of Xi values. So it's a new operator. I will skip the proof. So we have, let's say, X's and Y's. We have 2 classes of data in this figure. We have this function phi. This maps the X's and Y's to another domain. And this is the reproducing kernel Hilbert space domain. And in this new domain, we can develop machine learning algorithms using phis, or in fact, I have the formula for phi here. We can find it, but you don't need to use this phi. In fact, it's not practical because it's infinite dimensional. So you just convert the x's to infinite dimensions. So instead of generating these using these infinite dimensional functions, we just use this computable kernel dot product, which is summation I sine X I yi, minimum of absolute value of Xi times Yi. And it's computable and it doesn't consume energy, because it's minimum calculation is based on additions and subtractions, subtractions and comparisons, and sine Xi Yi computation is just a bitwise operation. And then we have the additions due to this summation operation. Okay, so that's the idea of this energy efficient operator. And then you can build neural networks based on these operators. In fact, there are also other versions. For example, we can come up with this. It induces the LP norm. So we are currently working on these. You can construct covariance matrices. You know, the covariance matrices are used in a wide range of machine learning algorithms. So instead of using 1/n-1 x transpose, you have lots of matrix multiplications in x transpose. Instead of that, we get the covariance, quote unquote, a kernel covariance matrix without performing any multiplications. And then you can carry out eigenvalue, eigenvector decomposition to generate machine learning algorithms. So this method is also robust. That's an interesting property of this because of the L1 norm. So let's say you have this data, it's a toy example. If you just apply the regular principal component analysis, you get this black line. There are robust principal component analysis methods, for example, and that gives you this red line. And our methods goes through the center. Okay, they go through the center of this data, and this data is this is because of the L1 norm property of our operators. In fact, I referenced the neural networks papers that we recently had. So, for example, this is our latest neural network paper. In this paper, you have convolutions in neural networks, so you can construct convolutional neural networks. Instead of performing multiplication, you just perform the dot product, our dot product. You can even construct this transformer neural network using our operator. It works, everything, because it's a well-defined, we have a well-defined mathematics behind it. It's a kernel covariance matrix, and it produces robust results. So I have here the regular convolution expression. So you replace the multiplication here with our operator, and you get YMN based on our operator. Now, the question is, can we train such neural networks? The answer is yes. We do some approximations here because we have to take the derivative of this convolution or the dot product, and the derivative is doable because the derivative has impulses, and this is the Dirac delta function because of the sine operator. Sine, the derivative of sine produces impulses, but we approximate the impulse with a Gaussian, sharp Gaussian, and that's how we train the impulse. And one disadvantage of the operator is that the training takes longer than the training of a regular neural network. But in many applications, the training is done offline. Therefore, you can get neural networks. One problem is that another problem is that in neural network, there is something called batch normalization. So we have to use also the batch normalization. You normalize everything by this batch normalization is used during the training or implementation. You have to normalize by the variance. So we do that, and it's our networks are not completely multiplication free, but the amount of computation is significantly lower than other networks. So these energy efficient networks can be used in practical applications, including autonomous driving, because they don't use energy consuming multiplications, and they can be implemented using simpler processors, and in fact, it can be possible to develop even GPUs performing based on this simple operation. Okay, thank you very much, and that's all that I want to talk about I think my time is also out. Are you listening to me?
Yes, thank you very much, Professor Setin, for this excellent presentation. So actually now it's time to open the proper some question if there is from audiences. So now in this room, please, if you have any question, so for Professor Setin or Dr. Coston, so you can drop your question in the chat box or you can raise your hand. So now is the time for some few questions. Okay, so actually I have one question. So for my curiosity, so from Dr. Kosman, so you talked about the energy management. So now the point is that how do you consider the status of the battery for this electrical vehicle? So if because you try to predict some road condition, and how do you consider the some status of the battery in the energy management?
Professor Karimi, there was a cut in your question. Can you please repeat it for me?
Okay, yes, sure. So my question is that when you talk about some road profile prediction, so in your presentation, so how do you consider the status of the battery? So in the management system, so do you use some features like the SOC or other parameters? So in the optimization.
Right, and that's an excellent question. And the battery management by itself is a wide research area. So in hybrid electric vehicle energy management, we consider definitely to lower the energy consumption. At the same time, what is really crucial here is the battery state of charge level. So during the entire driving cycle, for a given entire driving cycle, in the optimization, we include battery charge level, state of charge level. So we need to ensure that the fluctuations in the charge level is under predefined bounds. So this, for a single vehicle case, it is directly included in optimization. Using in the literature, researchers use a resistance model of battery because it is a really electrochemical complex device. For connected vehicle cases, they also include that battery charge level for hybrid electric vehicles, but the consideration more goes on not to deplete the battery or not fully use the battery, but to make sure that battery level will be under predefined bound given the safety considerations has been achieved. So as the safety considerations in a connected drive is achieved, battery management directly or indirectly can be included in the optimization. I don't know if the answer is enough for the question.
Yes, definitely. So thank you. But because this is a challenging topic and also coming to the presentation given by Professor Setin, so basically involving some cameras and then looking at some advanced signal processing. So maybe this could be a question for Professor Setin. So how do you think that in the smart mobility, so this kind of the high or efficiency processing can be implemented for the cars, for the for the mobile robots? So,
Yes, I mean, energy efficiency is important. These devices have many cameras, and they have to be processed for driving, autonomous driving, and furthermore, they have LiDARs. I mean, some of the systems have LiDARs. Tesla doesn't use LiDARs. So our one of our solutions is this energy efficient neural networks. There can be other solutions as well, but the machine learning algorithms require a lot of energy. As I showed you, they use currently GPUs, and GPUs consume a lot of power. Each GPU, there is some static at the background. So each GPU consumes a lot of power, so you have to reduce the power consumption of machine learning algorithms.
Okay, thank you. So because recently we have focused on some projects, so about the integration of the cameras. So for the autonomous driving for the some industrial application like AGV, and with the combination of the presentation today. So from the Professor Sepin and also Dr. Kusmon, for us was very informative. So to look at the energy efficiency and also the signal processing, computational time, and these are the very interesting and also challenging topics. So we noticed from your post presentation. So actually, I would like to thank both of you for this excellent presentation and also your time to give a speech for our journal of the complex engineering system. And very briefly, because as we noticed that Dr. Postman, he organized interesting special issue on this topic. So we also to encourage if the others would like to contribute our journal. So you're very welcome to look at the webpage of the journal. Either you can submit your as a regular paper, or if you think that it fits to one of the special issues we have on the journal webpage, so you are very welcome to submit your quality paper. So this is the basic of the journal to publish high quality in a shorter time in order to increase the visibility of your result in your community. So I have no points if no question from the audiences. So I would like to thank all of you for joining our webinar today. And a special thanks to the Dr. Kostun Sepin for giving the very interesting presentation. So the presentation today has been recorded and you can either find on some live stream platform like a YouTube, and also a copy would be available on the journal webpage. So this is our third webinar to basically organize today. And we are looking forward to next webinar, and I hope that you could be our next speaker, and we can learn from other colleagues. So thank you very much again, also to the colleagues in the journal office, because of the local time difference. So it's quite late. So in China, and they also organized a webinar today. And thanks to all of them. And then looking forward to see you in the next webinar. So thank you very much and have a good day or good evening, and see you